Pythagorean Theorem. If A and B are the lengths of the legs, or in other words, shorter sides, of a right angle triangle, be aware of that, and C is the length of the hypotenuse, then A squared plus B squared equals C squared. So once again, if A and B are the lengths of the legs of a right triangle, and C is the length of the hypotenuse, then A squared plus B squared equals C squared. So the sums of the squares of the legs is equal to the square of the legs of the hypotenuse. Tongue twister for you. Agreed? Well, probably easier if you see the shape. Triangles, right? That's what we're talking about. Triangles. Okay, what about triangles? Well, it's a right angle triangle, meaning it has a 90-degree angle or 90-degree corner. And always, your hypotenuse, or the longest side, which is called C, or the hypotenuse, is on the opposite side of your 90-degree angle. So, in that case, the opposite sides are the legs. And you can call it either A or B and A. The order does not make a difference, actually. So we have some examples, and then notice we have our Pythagorean Theorem formula down at the bottom. A squared plus B squared equals C squared. So once again, let's write over here. When you're working on your homework problems, I recommend you write at the top of your page, Pythagorean Theorem, A squared plus B squared equals C squared. And let's start with A. So technically, in our Pythagorean Theorem, we are replacing the A and the V value for the first example. The A is 2 and the V value is 7. So look at that. Blank spaces for A and B. Let's replace or place the values that we were given. That's a 2 and a 7. Once again, the order won't make a huge difference because both A and B are interchangeable on that side. And now we square them. 2 squared. 2 times 2, 4. 7 times 7, 49. So 4 plus 49 now gives us 53. So we have 53 equals C squared now. Now we gotta solve for C, meaning we gotta get rid of the square. What's the opposite of a square? What do trees have on the ground? Just a reminder. Roots, right? Square roots, tree specific in this case. We're taking the square root on both sides. That way we can cancel the square root with the square or the square with the square root. Another tongue twister for you. Square root of 53. That's where your calculator comes in. What is the square root of 53? So turn on your calculators, hit second, the square button gives you the square root, and we're doing 53. Once again, if you can't find your square root button, it's in the middle, on the very left side of column of your buttons. Okay, you press second, and then the x squared will give you the square root function for it. So there you go, 7.28 roughly. And let's remind ourselves that it's a square root, so we need a plus or minus, agreed? Whoops, no plus or minus. This is a distance, so for distance we don't require plus or minus. It's always a positive distance. If you measure from one side of the wall in your room to the other side of the wall in your room, is it going to be any different if you start from the opposite side to the original side, or vice versa? You're going to get the same distance, right? So in this case, it's always a positive number. Pythagorean theorem is one of those case scenarios where square roots, you do not need a plus or minus. You only need a plus, a positive side. So there's our answer, 7.28. B, once again, our Pythagorean theorem. In this case, we know the C value and the A value. So let's leave a blank. In our Pythagorean theorem, we have parentheses squared plus B squared equals parentheses squared. And let's place in the values. The C value is 13 and the A value is 12. So there's our A of 12 and C value of 13. And let's square them. Your calculator could come in handy, or practicing your multiplication. So we don't learn that far sometimes, right? Totally fine. So 12 carry key 2, or you can go 12 times 12 on your calculator. Should give you 144. 13 carry key 2, or you can go 13 times 13, 169. Okay, so 144 plus V squared equals 169. So now we're solving for V. So that means we're getting rid of the 144, so minus 144 from both sides of our equal sign. And your calculator could come in handy again. 169 minus 144. Notice I already have 169 there. If I hit subtraction, it gives me the previous answer minus 144. So it takes the 169 and subtracts 144. Gives us 25. So let's cancel our 144 and write down that b squared equals 25. Now to get rid of the square, be the square root, right? Remember those trees. So square root on both sides, square root of the square cancel out. What is the square root of 25? What number times itself gives you 25? I think I heard you say 25. Nope. 5, right? 5 is what I heard. So b equals 5. Positive and negative? Nope, no positive or negative. Remember, it's a distance. So b equals 5. C. Let's see. C. Once again, there's our Pythagorean Theorem formula. We're missing the v value and the c value in this case, which we're given that the v value is 6 and the c value is 8. There we go. Fill them in the right spots. So solving. Well, 6 squared. 6 times 6, 36. 8 times 8, 64. And now we get rid of the 36, minus 36 from both sides. 64 minus 36 will definitely give us 28. Once again, recommend you check with your calculator. I could be wrong. So a squared, getting rid of the square root on both sides then. Square root of a squared, the square root and the square cancel each other out, giving us that a equals 5 times 5 is 25, so it should be 5 point something. But that's where your calculator comes in handy. Second, x squared gives you the square root of, let's say, 28, which is what we're looking for in this case. Close your parentheses, hit enter. 5.29 is your rough answer. So our distance, roughly 5.29. I should have had a roughly 5.29 on A as well, right? Oh well, we'll leave it for next time. So look at that. We're pretty much done with our examples. Once again, note that for distances, we used only the positive value on the square root. Agreed? No plus or minus, it's just positive side.